Hey y'all, stay tuned for this video. We're going to show you how I designed, built, and flew this FPV and aerial photography workhorse. Welcome to 3D Aero Ventures. So last month we designed this awesome infinity wing design. It flew amazing, had a couple mishaps, but it was a fun learning experience, and for my first kind of fully 3D printed CAD design, I think it was a huge success. So getting a little bit more traditional with this plane. This is called the AirCam. It's actually modeled after a home-built aircraft of the same name called AirCam. But they actually designed it years ago in conjunction with National Geographic as a platform for aerial photography for their magazine and doing aerial video and stuff like that. I thought it would be really cool to do the same thing in an RC version and actually making it what I call an aerial photography and FPV workhorse. And I added some cool little touches where I can move cameras around to different spots. So you can see there's a hole here for a run cam, which is this little tiny aerial photography camera. And then I've got these hard points on the wingtips. You can see there's a GoPro on that one, and the run cam is mounted right here. So you can mount it on top of the wing on bottom, change the angles, and get some really cool views up in the air. This canopy would also be suitable for like an FPV system, which I'm going to experiment with in the future, so stay tuned for videos on that. But yeah, if you check this out, these basically are just little hard points that screw on with a nylon screw. Pops right out. And same thing in the canopy, I can just pop this in. Clicks in there, and then I can screw it in from the inside as the canopy pops off. So a lot of cool options, which hopefully you'll see. I haven't flown it yet, so we're going to take it out in a minute and give it a shot. I think we're going to get some really cool aerial shots for you in our first flight video. And if it crashes, we'll get some really sick video of it crashing, so that's pretty cool too. But some details about the plane. It's fully 3D printed out of PLA, just like our last plane. This has, as you can see, 2 motors in it. These are Leopard motors, 35, 36. 780 kilovolt motors, there's 2 of them. So it's equivalent of like an inflight Power 10. I'm running a 4-cell battery for each motor, so we should have plenty of power. It's coming in a little bit heavy. This plane weighs about 3,500 grams, which is kind of heavy for this size, but it's a large plane, as you can see, 60-inch wingspan. I've designed it with 5 channels. This is more of a traditional setup as compared to the infinity wing. Just ailerons, elevator, rudder, and I designed some flaps into it so I can do some real low, kind of slow flying, get some cool aerial shots that way. So y'all, thank you so much for watching. Stay tuned. We're going to hit that CAD and 3D printing time lapse so you can see how this AirCam came to life. So before we get into the design and build of the AirCam, I just want to give another big shout out to our sponsor SolidWorks for sponsoring this video, and they're going to be sponsoring one more coming early next year, so stay tuned for that. In particular, I want to call out their 3D Experience platform. I actually just dove into this for the first time for this project. They have some web-based software up there called XDesign and XShape. XShape I used for the wingtip design of this plane. It's a really intuitive way to just kind of push and pull points to create organic forms. So it helped me get this wingtip design just right. It's totally doable in SolidWorks Desktop if you're used to using that. I found XShape in conjunction with SolidWorks Desktop to be a really cool collaboration for this design. So SolidWorks, thank you. Now back to the video.
This design ended up taking several hundred hours, so I won't run through the whole process. I'll just hit on some of the high points of the design. Since this is a sport version of a scale aircraft, I was able to find some great images which I imported into SolidWorks to design around, using a few good side view and top view images to bring what I am calling the SportCam to life. As I mentioned earlier, I decided to experiment with SolidWorks web-based software called XShape to model a few components for this SportCam design. XShape is a 3D subdivision software which is ideal for modeling organic forms which require smooth transitions, just like the form of the wingtips on my aircraft design. Some may find it a more intuitive modeling experience over your typical parametric CAD program, as you're just starting with a generic 3D shape and pushing or pulling points, edges, or faces to mold the part into your desired form. Since I have a ton of experience in SolidWorks Desktop, I personally love how well XShape and SolidWorks play together, which allowed me to model the uniquely shaped wingtips of the SportCam in X Design and just import them right into place back in SOLIDWORKS Desktop to complete the design of the entire aircraft. One of the things I love about the original AirCam design is how the wing transitions from an aluminum covered wing at the root where the engines are mounted to a fabric covered wing on the outer wing sections. I really wanted to maintain the look of that fabric covered wing, so you'll see I'm incorporating that into the design here. I've also incorporated a really simple servo mounting design into the SportCam, where the elevator servo is mounted to a removable plate on the bottom of the horizontal stabilizer, and the aileron and flap servos are mounted in the same way on the bottom of the wing. I'll go into more detail on this during the physical build of the plane, but I've designed the center section of the wing to be permanently attached to the fuselage, and made the outer wing panels removable using some simple screw holes on the bottom of the wing panels. This fuselage design is somewhat skinny, so I thought it best to incorporate a unique rib structure that coils around the interior walls for added strength. So with the basic shape mostly done, I started splitting the parts into manageable 3D printable chunks, incorporating these alignment tabs into each joint, which makes assembly with superglue a breeze. Finally, the original AirCam is an open cockpit design, but they now offer a canopy which fully encloses the cockpit. I opted for the closed cockpit version, which will give me better opportunity to hide all of the electronics and give me more camera mounting options. So after hundreds of hours, I couldn't be happier with how the digital design looked. It was time to bring this SportCam to life. Just as you saw in my previous video with the Infinity Wing build, assembly of these 3D printed planes is pretty straightforward. It's just a matter of some light sanding and filing to ensure a flat surface on the mating surfaces, and to give the glue some grit to adhere to. And using good quality medium-bodied super glue, also known as CA, and some accelerator for instant drying. In cases where the two mating surfaces needed to be facing down on the 3D printer platform, I like to just place 3 or 4 holes for popping in these small alignment pins, which I buy off the shelf from McMaster.com. The landing gear is also 3D printed in PLA, but with a 50% infill for added strength, and it's just bolted on with 440 screws and lock nuts. Once all of the fuselage and tail surfaces have been assembled, I could screw the servos into the removable servo plates and hook up the control linkages. All of the control surfaces are hinged using a 1mm diameter carbon fiber rod that just runs all the way through the control surface. To me, this is a lot simpler assembly process than having to glue individual hinges. As I mentioned earlier, I wanted the SportCam to be able to break down for transport to the flying field. But since the motors are mounted to the wing, I wasn't wild about having to carry the whole thing around and plug in the motors every time. So I designed the center portion of the wing to be permanently attached to the fuselage, and the outer wing panels are removable. I used these awesome heat-set brass threaded inserts to create a super strong thread on the center portion of the wing, and I used a smaller 440 heat-set threaded inserts on the wing panels for the removable wing struts. So assembly at the field just involves sliding the outer wing panels on the carbon fiber tube, hooking up the aileron servos, and bolting the wings on from underneath. The wing struts are probably optional, but they screw on easily with 3 screws each, and make both the landing gear and the wings rock solid, so I chose to attach them for the maiden flight. As far as all of the onboard electronics, you'll see the details about the aircraft and the equipment I used in the video description below. And over the next few months, I'll be perfecting this design, completing full build instructions and a build video, and offering the digital files for sale through our website. For now, head to 3daeroventures.com and sign up for our newsletter to stay up to date on the availability of our latest designs. Now, with the SportCam fully assembled and my heart pumping, I was ready for the maiden flight. When I was in high school, I was lucky enough to go through private pilot training, and I received my pilot's license when I turned 18. But flying full-scale aircraft isn't exactly an affordable hobby for a college student. And once I had a family of my own, my priorities definitely changed. So I've since let my license lapse. There are definitely times when I miss the feeling, perspective, and sense of adventure you get while flying a private aircraft. That feeling of weightlessness you get on takeoff and when you hit ground effect just before touchdown, it's truly a unique experience. But this project has managed to bring me pretty close to that experience. I want you to enjoy some of this in-flight footage, so I'll shut my mouth now. Thanks for watching, and as always, remember, never stop exploring, never stop questioning, and never stop playing.